So I'm going to start on the yellow paper. So we've been talking about the parent functions. So the next thing we're going to do is transform, and then we're going to graph. So the general form so that's the general form of all of the transformations. So the A and the K are on the outside, right? The A and the K are on the outside. So those are, Ginger, going to be range changes. Inside, the B and the H, those are going to be back and forth. Okay, and sometimes the H and the K are C and D. It's all the same thing, okay? It's all the same thing. But H and K is usually the vertex, so that's why I write it that way. Okay, so C and D, sometimes it's C and D, but I think most of the time I'm going to write it with an H and a K, but it's all the same. Okay, so if I want to shift something down, I'm going to have the function minus K, or minus D, whichever is the same thing. But that's on the outside. You see, it's not on the inside of the parentheses, it's on the outside. And if I want to shift it up, I'm going to add K. Right across, if I'm going to flip it down, I would need it on the outside. So the minus sign is on the outside of the parent function. But when I go back and forth, that's with the X. And our X's lie. That's why we break up with them, because they lie. So if I'm going to the left, instead of minus, plus. And if I go to the right, I'm going to subtract. And the reflection across the y-axis, that's a back and forth, so that minus sign goes inside with the X. So up and down go on the outside, and back and forth go on the inside. So then we have Mason. She wants you to pay attention, she told me. Okay. Then we're going to have a vertical stretch and compression. And a vertical stretch and compression is going to be A times the function. And it's always going to be by a factor of A. And the A is on the outside of the function, just like the minus and the up and down. So the compression, the A, goes on the outside. So it's going to be a compression if the A is like a fraction. So if it's like 1/2 or 1/3 or 3/4, so the absolute value of A has to be between 0 and 1. And if the absolute value of A is greater than 1, so 2, 3, 4, that's going to be a stretch. So if it's bigger than 1, it's a stretch. If it's less than 1, it's a vertical compression, and it's on the outside. Okay? So the horizontal is going to be this. It's going to have the B with the X. And so we said this is multiply, right? But my X's lie. So instead of multiply, what do you think I'm going to do? So it'll become 1 over B. So it's going to be a compression if B is greater than 1. And it's going to be a stretch if B is a fraction. So on the back is a cheat sheet of what I just wrote. And so you probably are going to want to keep that handy for when we are graphing, which we're going to start tomorrow. Okay. So, starting on the blue notes. The first thing you have to do before you can even start this is you have to identify the parent function. So if I take away the numbers, what's the parent function here? It's the cubic. And if you sketch that, this is what it looks like. So what's different between the parent function and this one? Where do you think I'm going to do? What's that going to do? Shift 4 down. So on the next one, if you take away the 2 and the minus 1, what's the parent function? It's the square root, which would look like this. So this 2, is it written underneath the square root or outside the square root? Outside, that means it's vertical. So this is a vertical stretch because it's bigger than 1. It's a vertical stretch of 2. Is the minus outside or inside? This minus? See, the parent function, the minus sign is inside, right? It's not outside, it's in. Oh, okay. So, but the minus sign is in the parent function. So that means it's reflecting over the y. And then the minus 1 is really a shift to the right. So the parent function on number 3, if I take away the minus and the 1/4 and the plus 6, the parent function is going to be the quadratic, which will look like this. So if this is the parent function, then the minus sign is outside, so it's in front, so that's a reflection over the what? X. The 1/4, it's inside with the X, right? That makes this a B. This is my B. And so this is horizontal. So look on your yellow sheet on the other side. What do I have to do with the B? Our x's lie. So instead of multiply, what do? I have to divide. So I'm going to take 1 over 1/4. And what happens when I do 1 over 1/4? Nothing? We're just going to leave it that way? I got all day.
4.
It becomes 4 because the bottom gets reflected, so it's going to be 4, and so that's going to be a horizontal stretch of 4. And we're going to go 6 up. Okay, everybody. Okay, so first of all, what's the parent function? It is. Which looks like this. So next, is the 3 inside or outside? inside, which makes it horizontal or vertical? It's the B, right? So it's horizontal. And so it's a horizontal stretch or compression. And the +5 moves it which way? And 2 down. Yes. So it becomes 1/3. Okay, so next I'm going to do number 6. So the parent function for number 6, if you take away all the numbers and the minus sign, it's 1/x, which is the rational or the reciprocal, either one. And so this gets graphed like this. So the way this is written is really this. That's really how it's written. So that makes the -1/4. I'm just going to hold this for you. It hurts my feelings. Yes, it's all about me right now. So this is how this is really written. It's 1/4 times the 1/x with the negative outside. So if the negative is outside, that's a reflection over what? Correct. The 1/4 is also on the outside, so that's your A value. So is that vertical or horizontal? So it's a vertical compression. And then 3 up. Okay, number 9. It's the absolute value of x, so it looks like this. So is the negative inside the parent function or outside? If it's inside, that means it's back and forth, which means it's a reflection over y. That makes this a B value. So 1/3 is my B. So what do I have to do with the 1/3? I have to put 1/1/3. So what does that become? 3, which is going to be a horizontal stretch. The -4 will be 4 to the right and 7 up. So on the back, number 11, this is the absolute value. So if I'm going to translate 2 units right, so I wrote it with a G because the parent function is f, and so once you transform it, you change the letter to show it's a different function. So this one I'm going to reflect over the x and translate 5 units up. So if I'm reflecting over the x, does the minus sign go inside or outside? It goes outside. So I'm going to have g of x equals negative x and then up 5. Okay, we're going to come back to number 12. Go down to number 14. What's the parent function here? the cube root because it's laying down. So I'm going to reflect in the y-axis, so that means the minus sign is going inside, and translate 4 units to the right. Okay, horizontally compressed by a factor of 1/2. So what do I have to do with that 1/2? Right, so I do 1 over 1/2, which means it's 2, and translate 5 units down. So I'm going to have the cube root of 2x minus 5. So go back up to the rational. So the parent function here is 1 over x. So the first one, I want to translate 7 units down and 3 units left. 7 units down, 3 units left. So the 7 down, where does that go? Outside, and then the 3 units left. That's what that one looks like. This one, horizontally stretched by a factor of 3. So what do I have to do with that factor of 3? It's horizontally stretched. So I do 1 over 3. So watch, this is how you're going to write this. If you wrote it, you would do 1 over 1/3 and then x minus 2. Can I have a 1/3 in the denominator like that? No. So what happens to it? What does that become? 3, right? So I'm going to write it like this. It'll flip over. Okay, 2 more. Number 15. If this function, I want to start with this function, and I want to do all of these things to it, and I want to end up with a new function. So the first thing, I'm going to reflect across the y. So where does that minus sign go? And so my parent function is x squared, right? So the minus has to go inside. So I'm going to have g of x equals 2. So then I'm going to translate 6 to the right. Translate 6 to the right. So if I start at minus 5 and I'm translating 6 to the right, minus 11. And then the plus 3, I want to go down 2. So where would I end up? Plus 1. Okay, so we started, and this is where we ended, right? So on the last one, this is where I'm going to end up, and I want to know where I started. Okay? So a function is vertically stretched by a factor of 2. So that's my A. So if I'm vertically stretching by 2, that means I multiplied some number times 2, and I ended up at 6. So what did I multiply by 2 to get 6? I multiplied by 3. So now I ended at plus 4, but I shifted 2 units to the left. So it's x plus 2, right? Because that's a subtraction. And then I shifted 5 units up. So where did I start? Plus 4. So if I end at negative 1, yeah, minus 6. If I moved up 5, I had to start at negative 6.